Hmm. All right. Let's get right to it. For Charlie. Okay. I see you. You're in chat now. Good. For Charlie, identify basic facts about characteristics of Tropo's satellite support radio, better known as a TISR, or the AN/GRC-239. As always, you got to get more than 28 on the test out of 40. AFSC application, you're going to get to play with it starting on Monday and Tuesday. Test out Wednesday, correct?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good. Monday we'll probably do appraisals. Tuesday we'll do a review. Hope everything works out at that point. I'll look at the schedule and find out what should be the best time for that. We're going to look at purpose, operating characteristics, type of traffic, equipment, and we're going to stop at signal flow and go through the tech order, and we'll be done for the day. So what is the purpose? Well, full duplex, LOS, radial terminal. Does anybody know what really full duplex means?
Can transmit and receive simultaneously.
Okay, in the wonderful world of radio, there's more to it. Anybody want to add to that?
No, sir. How does it work in radios then?
Okay. Rich Snow is going to hopefully educate us. Oh, I see. 1300. Okay. I'll take that under advisement. Now, with full duplex, everybody thinks transmit and receive at the same time, but in radio world, it can't transmit and receive at the same time unless they're different frequencies, because then it would have a problem in interfering, and you're going to see it when you get to the TISR. That's the way satellite works. That's the way the radio repeaters work. I don't know of any that gets on the same frequency. Now, when it comes to cell phones, it's a little bit different. They have channels, but it still works the same way. You have a frequency that is broad range, and then there are channels within that frequency, just like you have channels within your IP modem. For example, Wi-Fi, 2.4 or 5 gig. In fact, they came out with a new one. I'm trying to think, is it called fourth generation or something to that extent? It has. Go ahead.
Is 5G, sir.
5G, okay. Fifth generation router modem. It goes 2.45, and it's gigahertz. And the last one is actually 60 megahertz. And the reason that they look at that is there are a lot of homes where they'll set the modem router the closest to where the input is from your telephone or internet, whatever it is, whether it's cable or you figure it out. Anyway, it'll be on one side of the house, but they can't quite get the signal to the opposite end. But the way to look at it is your lower frequencies don't have as much throughput as the higher ones. So it's a give and take society on that one. They do this for ranch homes as well as 2-story homes, 3-story. So that gives you an idea how this full duplex, when you have to deal with two different types of frequencies in the wonderful world of radios, as well as cell phones. So this particular device, the Jerk 239, is lightweight and field tunable. I'm not sure I'd call it lightweight because it has 3 transit cases, and each one of those transit cases has a 2-person lift on it. It can connect to satellite terminals as well as about anything else. If you can think of it, it could probably do it. You just got to figure out how to get it in there. Designed for quick deployment, it is transportable. That is definitely transportable. toss it in the case, put it on a truck or a train or any type of airplane that will fit those transit cases. It is short setup and teardown times. Takes you probably the first time you doing it and going through all the checks, take you about 45 minutes to an hour. It is reliable in adverse conditions as long as you have the weatherproof front covers and your ping pong ball on top of the waveguide has not been destroyed like we have. Our operating characteristics is 14.4 to 15.25 gig. Power output is 25 dBm, better known as 316 watts. dBm is different than dB. dB is a reference versus dBm is an actual measurement. Its IF frequency for receive is 70 megahertz, the max range. Look at that sign. It says less than 25 miles. And the reason why it's less than 25 miles is it deals with meters or kilometers. And you're going to see it when we get to the TO. It has 3 types of different traffic. You got CDI, conditioned diphase. You have pseudo NRZ, which is something a little bit different. The easiest way to explain it is pseudo, meaning it's kind of like NRZ. It's the best way I can describe it. You have analog or digital voice order wire. So that is your auxiliary channel that's going to go along with either one of the conditioned diphase or the pseudo NRZ. There are 2 assemblies that come with it, baseband assembly and an RF assembly. There are the setups of this assembly. You can separate the baseband from the RF. You can put it in a 19-inch rack, or you can combine it with the RF assembly on a tripod. Or you can just put it on a table or anything similar to that. With the RF assembly, you can put it on a 50-foot mast. Now this one is, if you were to go back in Block 4, you will find out if you take a look at the front panel of each one of those the CTM15s, some of them are going to have CTM15, others are going to have Jerk 239 on them. It does come with a 50-foot mast identical to the CTM. In fact, they're one and the same. I can't tell any difference between them. That mast also comes with 4 sets of guy ropes, and instead of your 1.5-foot stakes, they're actually 2-foot stakes. And the loading for that is, the reason for that is you're going to put the RF assembly, which is about 20-some pounds, on top of it and lift it up. And that's definitely an upper body workout for that. The RF assembly can fit on the tripod, which is what you guys will be doing. And then, of course, if you get a rigid pole, like a telephone pole, power pole, whatever you want to call it, you can attach it to it. The only time that the RF assembly will not go on a mast is when you install the 2-foot dish. That's a big no-no. At that point, you're going to end up breaking that mast. The baseband assembly contains what we call 5 LRUs, line replaceable units. What does that mean? Well, with each one of those screws at the top and at the bottom, on my power supply section here, you can unscrew those, pull it out, and be able to disengage a card from those slots. And that's what you're removing and replacing. You can't remove components because from what I've seen on them, they come with this glaze over top of it. And it's very difficult to defeat the glaze in order to remove a component. The 5, go ahead.
Coating, sir.
It's what kind of coating?
Conformal coating or conformal coating.
Okay.
It's like an epoxy resin that goes in circuit boards to keep humidity and moisture out. Yes.
And if you've ever tried to defeat one of those, they are a pain. You got to get out the Dremel tool. But very hard. All right. Those 5 LRUs, okay, is order wire, transmitter, receiver, breaker panel, and power supply. Yeah. Let's try that again. Power supply. Now, on these panels, you'll notice that on this baseband assembly, there's 4 of these things that you can pull out. Wait a minute, we just said 5. The power supply unit actually has 2 behind this. If you were to pull the card, you can pull the breaker assembly out, as well as on the side, the right-hand side of this power assembly, is the power itself. In other words, the DC from AC to DC portion. So that is probably, I want to say, like a 5-inch by 10-inch, and I want to say about 2 inches thick on the side of that baseband assembly. That one you're going to need, a screwdriver in order to pull that out, but you got to disconnect it from the inside. Next up, we have the RF assembly. This one has 3. Now, all 3 cards are back behind the RF assembly front panel. You can use the RF assembly with the 1-foot or 2-foot antenna, and you can connect it between the baseband assembly and the RF assembly either with a 2-foot, which normally you would use for the tripod. However, if you want to keep those things separate, like you want to put it on a pole, you want to put it on a mast, or you want to put the baseband assembly in a nice, comfortable, air-conditioned tent, you're going to use the 150-foot cable that comes with it. Here's where you start to see the frequency diversity when you see 200 megahertz apart. Now, I'm going to point out something to you that's in the TO and is explained, but we've gone through so many thumb wheels that we can't even replace them anymore because the equipment is no longer supportable. If you take a look at your front panel assembly here, I'm going to blow this thing up. You can see that on the left-hand side of the 2 thumb wheels, there's a 1 embossed on the front panel next to it. This 1 never changes. This second number from going from left to right is a thumb wheel. That can only be changed between 4 and 5. The reason why they're broken is we had airmen that would go in there and trying to put a 1 in where the 4 or 5 would go. That would break them. If you find one that has the thumb wheels still intact, where it has a stop on it, you will find out it won't go beyond 4 or 5. So that's the reason those 2 are, you can't change the 1s, but you can only change to a 4 or 5. Now, if you get one that you can change from 4, 5, 6, 7, 8, 9, 10, you know you got one of the broken ones. Now, I can tell you right now, maintenance has done this. They have pretty much locked in the number on that thumb wheel, and there will be a piece of tape over top of, right above the receiver frequency, explaining which one of those you cannot touch. Or they'll say locked into either 4 gigahertz or 5 gigahertz. Now, you'll also notice at the top thumb wheel here, it says receiver frequency. When you get your cut sheet, it's going to have the transmit frequency first and the receive frequency second. We get a lot of this out there in the field, or I should say in lab, where they'll put the transmit frequency in where the receive frequency is, and the other, the receive frequency where the transmit frequency is. Not a good thing. One other detail that we see a problem of is when it says enter in your receive and transmit frequencies, you may have your receive frequency in the correct spot and your transmit frequency in the correct spot, but everybody forgets about this little knob right down here, bottom left-hand side. It says receiver frequency. I'm here to tell you that that is a pre-selector filter and you need to change that. If you don't change it, you run the risk of when you flip this into the operational mode, you're not going to get anything. Then we have this channel error light that I want to talk about real quick before we go on. This channel error light, if you hadn't noticed, that we talked about the frequency range of 14.4 to 15.25. The 14.4, you can actually put in 14.3, you can put in 14.2, 14.1, you can put in 1400. That's a problem because it's under the frequency range. If you're at 15.25, you can go 15.3, 4, 5, 6, 7, 8, and 9. You're outside.
In the push-up section.
What the heck? Somebody doing their exercises when they should be listening to what's going on here? Hello? That was a crazy one. Anyway.
I'm sorry, sir. I accidentally pressed the button on my computer.
You know, we had an old saying, if it ain't broke, leave it alone. Or if you're in the Tim the Toolman Taylor phrase, if it ain't broke, it can be fixed better. Yeah, understand. Anyway, you're forgiven. It just caught me off guard. Anyway, what I'm trying to emphasize here, you see the channel error light that's above the summary alarm? Summary alarm is red. Above the channel error light, that's white. Now, if this is outside of the frequency range, the operational frequency range, that channel error light will illuminate. Okay? Illuminate when it's outside. If there's a problem in the RF assembly, you're probably going to see the summary alarm on top of it. Now, hopefully I explained that enough to where when you get to it on Monday, you'll go, oh, Mr. Mayor told us about this. With the antennas, there are two different types. Actually, should be classified as dishes, not antennas, because the antennas is internal to the RF assembly. But we do have a 1 foot and a 2 foot dish. We also have a small and a large waveguide. The small waveguide goes to the 1 foot. The large waveguide goes to the 2 foot. You can see that it can be mounted. The RF assembly can have the 1 foot dish. It'll go on either the tripod, pole, or mast. However, when you get to the 2 foot dish, it can only be mounted on the tripod or pole. Remember back when I said this morning that our gain is in direct relationship to how big our dish was? Well, the bigger the dish, the more the gain. Well, you can see it just from this slide going, the 1 foot has 31 dB of gain and the 2 foot has 37 dB of gain. That's pretty significant. So we're going to stop at the transmit, receive, pass, standby, loop, back, and order wire for tomorrow morning at 9 o'clock. Let's pull open our tech order. Should be something along the lines of tropospheric satellite support radio PDF 3D 133-7-9 Bravo PO extract. That's the one we're going to be going over. So if you have this on, say, PDF file, there's this nice little, up at the top right, a highlighting text. If you can do that, I would suggest that you highlight it and use it. So we're going to go through our tech order. And the first place that I'm going to go is Chapter 1, General Information. Now remember the first part of our slideshow, we talked about the purpose. Right here it is, 1.2. Doggone it. I got to get the original one out. Apologize for that. The one that I've got highlighted. Oops, NSM. You would think by now, here we go. See if this fits. All right. There we go. Purpose of equipment, equipment description, left-hand side, but the big one that I'd like to go over is 1.3.1 typed traffic, because it requires a little bit of explanation here. You can see that it carries the first sentence here, a 3-volt peak-to-peak conditioned dye phase, as well as a 3-volt peak-to-peak pseudo NRZ. Now, most of our equipment, when it comes into our multiplexer or our baseband assembly, we're going to have to attenuate it probably down a lot in order to get to the 3-volt peak-to-peak condition. You can see we have a range of 0.072 to 4.608 megabits per second. Okay? That's for CDI. Conditioned dye phase is CDI. When you go down further, it shows you the analog or digital voice, order wire. The next one we have the pseudo NRZ. It's 6.144. This is fiber optics. Now, the easiest way to determine what you have is if it has a Canon plug on the back of the baseband assembly, and that's where you got to plug it in, then you know you're dealing with CDI. If it has two BNC cable looking devices, that's fiber optic. When we look at other configurations down here, you can see that the mast is installed, the tripod or a pole. When that's in 1.3.2 for typical deployments. We also have 1.3.3. They talk about the accessories that come with it. You get 2 weatherproof assemblies mounted as a single unit or separate by 150 foot of supplied cable. It normally comes with 2 foot for the tripod. And I'll show you where that's going to be at. RF circuits, so the receiver, notice I said receiver, it says 70 megahertz IF. You can see down at the bottom of the sentence, or bottom of the paragraph, it says radiation of RF energy is via either the 1 or 2 foot diameter antenna, and you can use the 1 foot for the simplifies direction and alignment path. You know, that's true, but that horizontal or vertical polarization is stuck in there. That's your frequency diversity versus polarization. And you can see that we have a mast. On the top of this mast, you'll see that we have this nice little device. Last time I checked, it was still on block 4. I don't know where it's at now. It might actually be in block 7 there for you when you're doing the tissers. It fits on top of the mast. Now, equipment configurations. Number 2 on 1.4 says when deployed with the 1 foot diameter antenna attached to the RF assembly atop a 50-foot mast. Okay, so now you actually see on paper what's going on here. When it's deployed with the 1 or 2 foot diameter antenna attached to the RF assembly atop a tripod, or number 4, it says on a pole. So as you can see, the 1 foot can be attached to everything that's available, which is the mast, the tripod, or pole. When you mount the 2 foot diameter dish on it, you can only. You cannot put it on the mast. That's an easy way of saying it. And this describes most of the other equipment. This is what, right above me, the RF assembly and the baseband assembly fits into this metal case. Do not attempt to pull it off or put it on the wagon by yourself. It's a two-person lift. It has it on the darn case itself. You can see that inside the case, you can see number 1, it says the RF assembly, and number 2, it says the baseband assembly. What does it come with? Well, it comes with a handset, a headset. There's some cables, which I think this is number 3 is loopback test cable. Better known, number 4 is a 2-foot jumper cable. We do not have the number 3 in there. We do have number 6 in there. Now, where does this all fit? Right here on number 8. Okay, so when you pull these things off, be cognizant of where that case is that has the headset, handset, 2-foot cable, and the electrical cable. This is our transit case for the antennas. You'll notice that we have on, I think it's on the top part of the case inside, so when you open it up, you will see the 2-foot on the lid, and on the bottom you will see the small waveguide here and the larger waveguide here, and next to it off to the right, number 4 here, that's the small dish. Number 5 and 6 are your accessory kits. What does that mean? It means you have stakes, guy ropes, and anything else such as that piece that will fit atop a 50-foot mast. Works similar to the AT-197 when you put it in that keyed hole. It is keyed. So you slip it in the hole, twist it, and it locks into place when it falls down into it. There you go. There's some more information on number 6, which is that antenna tilt assembly. Here's your tripod. It is in a separate case. You'll have what they call it, a T-handled hex screwdriver is what I like to call it. You also have the pan head tilt assembly, and you have what I call the pan, called a mounting plate. This is where you're going to attach this or 2 as well, or RF assembly and baseband assembly. This is what it looks like when you hook up the RF assembly to the mast, as well as the 150-foot cable with the baseband assembly inside of, in this case, the case. RF assemblies on the top. Here you go. This is the front panel. The dish. The baseband assembly. Now, remember I told you it was 70 miles an hour when you got the RF assembly on there with the 1-foot dish? It says wind speeds up to 70 miles an hour. Why is that versus when you put a CTM up? Well, CTM up only has 3 sets of guy ropes. This one has 4 sets of guy ropes, and you have to position them different than what you were with the CTM. You also have 2-foot stakes instead of 1.5-foot stakes. So there's a lot more rigidity to the mast when you install them with 4 sets of guy ropes. This gives you an idea of when they go into the transit cases as well as them by themselves. RF assembly, weight, 16.5 pounds. That's a lot of weight to be lifting up. Add the tilt assembly to it, you're probably looking at about 18 pounds. Leading capabilities and limitations. Capabilities and limitations. So here on table 1-2 in chapter 1 is where you get the bulk of what this thing can do. You can see our RF power, our frequency range, the RF assembly and what it's going to do, the baseband assembly, and then you have your antennas. This is an excellent place to look if you're trying to find out information that's very basic about the tisser. You got the 1 foot and you got the 2 foot. Now, remember I told you about the meters? Well, less than 10 miles is 16 kilometers. Okay, so if you measure this out, it's less than 10 miles. That's the reason why that less than sign. If you look at 25 miles, it has a less than. That's because at 40 kilometers, it's less than 25 miles. So those are your dishes there. So let's see what else. You can see that here's your 2-foot cable right here. Well, let's do this. Forgot to, there you go. 2-foot cable, handset, headset, power cord. There you go. Let's see what else we got on the agenda. Chapter 2, yep. There's another 2-foot. Here we go. Section 2, installation procedures. Okay. Installation manpower and man-hour requirements. Not to be confused what your requirement is in the classroom. And when you're looking up this, they're saying on a tripod 1 man-hour. That's one person doing everything and linking it all up. With the mast, it's 4 man-hours. Now, with that in mind, the minimum amount of people that you can have on a mast, get this, 2. You guys put up the CTM with 4. So they're looking at it from a 2-person standpoint of raising the mast, maybe lowering it, locking everything in place, raising it some more. There is a technique, and that's the reason why it's 4 man-hours, of where you lift it all the way up to the green ring, you lock those cables into place because you already got them labeled. Then you lower it, and then you raise up everything to, I think it's the brown ring is next. Lock those cables in place, pull it all the way down, and then you extend all the way to the top to the black ring, and then when you get to the black ring, everything is already done with the first 2, that all you got to do is lock in that last set of guy ropes. Of course, there's 4 sets, and every one of them are positioned in a different area. That just goes to show you. In the poll, the reason why they said time required is installation specific. That means that, hey, I need to get a cherry picker out there because I don't have the equipment available to climb it and install it. So that's what it means by that. Let's see here. And you could go through this for your own leisure. You can see it's the same way that we put the cables on and take the cables off. Tripod mounted system, 1 or 2 foot. Just goes through some of this stuff that you can pick things out. We're just highlighting it until I get to the next segment, which is chapter 4, operation. This is what you guys are going to be doing starting on Monday. You're going to be going through the operation thing. And this part right down here on 4.3.1.3 is showing you how to set the thumb wheels. So just giving you an example of how you're going to set the thumb wheels, and again, it's pointing it out to you. This table right here in chapter 4 is extremely important. on page 4-3. It tells you everything that you need to know. In this case, this is the RF assembly. Everything on there, it tells you what it is going to do. And why is it going to do it? See, I got channel error and summary alarm, as well as the transmit frequency and receive frequency on them. Then we get to the baseband, which is table 4-2 on page 4-4. Again, goes right through everything and explains what's supposed to happen and what you shouldn't be seeing. Okay, so chapter 4 goes through what you're going to be doing. We're going to give you a cut sheet as well as the TO extract so you're not dragging the whole TO out. And then we get into chapter 5. Chapter 5 is the theory of operation. We will be looking at that tomorrow morning and going through the signal flow. Everything that I talk about in the signal flow is referenced in this particular TO through transmitter operation, receiver operation, your order wire and intercom, and your loopback testing. So we're going to be probably knee-deep in C's and D's tomorrow, going through what this tech order is saying to us. So here's the transmitter operation. You should have the C's and D's for, I think it's on pages 4 and 5, and 6 and 7. 4 and 5 is the transmit path. 6 and 7 is the receive path. With that in mind, I suggest very highly that you pull them up as we are going through them. And this side is the receiver operation right here. That is pages 6 and 7. It talks about where we start from to where we go. For example, on the transmit one, we start at the baseband assembly and go all the way through to the RF assembly and then out the antenna. For receive, we start at the antenna, pull it into the RF assembly, and then go to the baseband assembly. We have order wire operation, and then we have loopback testing. You can see that this is not a whole lot in this. And we don't go through built-in test anymore because of there just wasn't enough time in the course. Now there is. The bottom line here on built-in tests is if you're seeing the summary alarm illuminate, that's when you got to start thinking about, okay, where is it? Is it in the RF assembly or is it in the baseband assembly? Once you make that justification, you, the student, have no other choice but to tell the instructor and say, hey, I think it's the baseband assembly or the RF assembly, and we got to turn in the maintenance. So that part has pretty much been taken out of our lovely course. And of course, it's going to show you this is, I think, yeah, order wire, and the other one should be built-in test. Yeah, okay, this is loopback. There's another one in here, should be testing. Anyway, that's all of the tech order that we need to look at. Is there any questions? I know it's a wealth of information. Questions?
Sir, is this going to be the only TO we have on the test, or is there another
Negative. You're going to have the NSM tech manual. You're going to have this tech order, which is a Jerk 239. You'll also have the electronic C's and D's, and you have paper ones if you want to use them. When you go to the testing lab, you'll be given a disc and the option of being able to use the paper ones or the electronic ones.
Sounds good.
Anybody else? This turned out quicker than I thought it would be. All right, we'll see you tomorrow morning at 9 o'clock.
Yes, sir.
All right, see you then.
Yes, sir.
Thank you, sir.
You're welcome.